Teacher's Handbook, a great tool which bridges curriculum and classroom. It helps teachers plan lessons, use activities, and connect the book with real life teaching. It helps teachers in many ways. What is Teacher Handbook? It is a great support tool designed to help teachers guide students in mastering their learning outcomes. It supports teachers to help every child understand and succeed. It is an extra resource that gives teachers important information, skills, and easy methods. This helps teachers teach lessons in a better way and makes learning easier for students. Really, it is a great complementary resource. A practical guide. It is a helpful guide that shows teachers what to do in the classroom. It has simple tips, good ways to teach, and activities for students. This makes teaching very easy and learning better. It is a flexible aid designed to save time, reduce workload, and provide adaptable solutions tailored to the diverse needs of the classroom. What is the purpose of the Teacher Handbook? For curriculum interpretation. To support teachers in understanding curriculum goals, learning outcomes, and competencies as defined by SCRT-AP and National Curriculum Frame. Pedagogical guidance. To provide teachers activity-based, learner-centric, that is, child-centric, and inquiry-driven teaching strategies for each lesson. Lesson planning support. To provide model lesson plans, period plans, creative teaching learning material, and assessment strategies. Support to differentiated teaching. To suggest practical strategies to meet the needs of diverse learners, including children with special needs, first generation learners, and inclusive classrooms. Let us know the objective of the Teacher Handbook. To help teachers learn about good teaching methods. It also gives them simple tools to think about their own teaching and improve it so they can grow and become better teachers. It provides ready-made lesson plans that teachers can use directly, matches with the Teach tool, teaching through fun activities, tips to manage the classroom well, ways of teaching that suit each class level, follows the school timetable or academic calendar, critical thinking questions creation, sample tests and student activities, useful online links for the more help. These are the objectives of the Teacher's Handbook. Let us know the key elements of Teacher Handbook. First one, we have to discuss concept map. A concept map is a visual diagram that shows the relationship between different concepts within a topic or a subject. It helps teachers plan lessons and helps students see how topics are connected. It makes learning easy to understand. Here is a concept map of quadratic equations for the class 10th. Let's learn some more about concept map. It is a powerful support tool. Every concept map is a visual diagram that shows how different topics or ideas are connected. It helps teachers and students see the big picture, understand topics clearly, and learn step by step. What are the benefits to the teachers? It makes lesson planning easier and faster. Acts as a visual chart while teaching. Helps teachers and students link ideas in their minds. Makes complex topics simple to explain. These are the benefits to the teachers of concept map. Let us talk about a key element of effective teaching, that is learning outcomes. As we can see, this slide is divided into two parts. On the left, we will explore why learning outcomes are so crucial. On the right, we will look at some clear examples. First, the importance of learning outcomes in the lesson planning. They define clear goals. A well-defined learning outcome specifies exactly what students should know, understand, or be able to do by the time the lesson is complete. They ensure focused teaching. Learning outcomes act as a compass. By having a clear target, we can keep our lessons focused, prevent deviation into less important topics, and ensure that our valuable time is spent on the most essential concepts and skills. Third one, they guide instruction and assessment. When we know what the end goal is, it becomes much easier to plan how we will get there. Learning outcomes help teachers choose appropriate activities, select relevant resources, and most importantly, design assessments that are truly aligned with what we want students to achieve. Now, let's move to the right side of the slide where we have examples of well-defined learning outcomes. LO1, LO2, LO3, LO4, LO5, LO6. Apply concepts in real life, justify conclusions mathematically, define or analyze math concepts, understand relationships, collect and interpret data, perform operations confidently. Let's continue our discussion on learning outcomes. This slide provides a more concise summary of what they are and what they do. First, the most fundamental purpose of learning outcome is to define what students should be able to do after a lesson. It is clear, measurable goal that we set for every class. It shifts the focus from what we as teachers will do to what the students will achieve. Because of this, learning outcomes are the backbone of focused, aligned instruction. They create a clear connection between what we teach, how we teach it, and how we will know if the students have learned it. Every activity, every question, and every resource is chosen with the specific outcome in mind. Now that we have discussed the importance of learning outcomes, let's turn our attention to the resources available to help we achieve them. The slide is titled Teacher References, and it is a guide to some of valuable tools and materials we can use for lesson planning and delivery. Let's go through the one by one. First, we have a textbook link. This provides a direct digital access to the core textbook for this subject. Next is a link for chapter-wise content PDF. This is a fantastic resource for quick planning. Moving down the list, we have unit-wise activities from sources like Byju's. Websites and platforms like this are excellent for finding engaging supplementary activities that can make our lessons more interactive and dynamic. To help with assessment and practice, there are chapter-wise tests. We will notice a reference to SCRT here, which is a great source for validated and curriculum-aligned tests that we can use for formal assessments or as practice sheets. Let's move on to another crucial element of lesson planning: teaching learning material or TLM. It is a overview of what TLMs are, why we need them, and how to use them effectively. On the left side, we see some examples of specific teaching learning material: GeoGebra, PET simulations, quizzes, worksheets, video and quadratic equations. GeoGebra and PET simulations are fantastic digital tools for mathematics and science. whereas Quizzes is a popular online platform that makes assessment fun and engaging. Worksheets are a classic and still very effective form of TLM. And finally, a simple video like on quadratic equations can be used to introduce a new topic, summarize a lesson, or provide a different perspective on a concept. We will notice that the column in the middle calls these resources a flexible aid. This is a key point. TLMs are not just rigid tools. They can be adapted to fit many different teaching situations and student needs. Now let's look at the two boxes on right side, which explain why we need this material. First, the use of TLMs enhances teaching quality. They provide ready-to-use resources that make our lessons more engaging, effective, and memorable for students. They also save preparation time. A lot of high-quality content and structured activities are already available, which means we don't have to create everything from scratch. Teaching learning process. 40 minutes preparation is given here. First activity, it takes 4 minutes. This activity helps to grab students' attention and activates prior knowledge to set the context. Explicit modeling, I do, the part of teacher, the role of teacher. It will take 8 minutes. Teacher demonstrates the skill or concept clearly, setting a strong example. Group work, we do. It will take 16 minutes. The teacher encourages collaboration, discussion, and peer learning among the students. Independent work, you do. It will take 8 minutes. Allows students to apply learning individually, reinforcing understanding. And finally, closure, it will take 4 minutes. Wraps up the lesson with a quick review, reflection, or takeaway to solidify learning of the student. These are the steps in teaching learning process which will take 40 minutes of time. We can find QR codes which give more useful information to the teachers. Provided QR codes for each lesson in teacher handbook for easy access. QR codes on calendar provides information of no back day activities, information of cluster meetings, and resources for the teacher. QR code is also provided in the teacher handbook for additional information provided for teachers' requirement. QR codes provide instant digital access to detailed lesson plans, saving time and improving efficiency. Teachers can simply scan and retrieve the right content without searching through multiple pages or files. By adding usage of vocabulary to the teacher handbook, we make important terms or keywords clear for both teachers and students. Here is an example given for you. It is a great move to introduce misconceptions in teacher handbook. A small misconception leads to big mistake. A student never do any mistake while doing calculations or while learning mathematics. This handbook integrates a range of instructional strategies to make learning meaningful and engaging for students. The key pedagogical approaches include GRR, gradual release of responsibility. I do, we do, you do. Book activity, induction or introduction. CFU, text for understanding, critical thinking skills and remedial support. All these approaches are thoughtfully embedded in each lesson to support conceptual clarity, student participation, and inclusive learning. Book activity. It is a short, engaging introduction at the beginning of the concept. It is designed to spark curiosity. It is designed to grab attention towards the lesson and the activity which connect their new topic to the students. Here is a hook activity from the probability lesson. GRR, gradual release of responsibility. In 3 steps: I do, we do, you do. I do, this is teacher explicit, that means teacher modeling. We do, guided practice. You do, independent practice. This responsibility releases from teachers to student. In I do, the teacher explicitly demonstrates the concept. In we do, the students practice the skill with the teacher support. You do, students apply their learning individually, reinforcing understanding and confidence. Why GRR? It builds confidence and independence, ensures deep understanding, supports all learners, promotes active learning. Let us see what is I do. I do explicit teaching. This is teacher modeling. Teacher models and explains the concepts, and he think alouds to demonstrate reasoning. For example, solving 3x plus 7 is equal to 11 step by step. That is the teacher explicit. That is I do activity by the teacher. Now let us see what is we do activity. It is guided practice activity. Students collaborate with the teacher's guidance. For example, solving 5x minus 4 is equal to 7 with support. What strategies are using? Shared demonstration, guided practice, collaborative work, questioning, prompting. Now we move on to GRR you do. The last stage of GRR. Students solve problems independently. They will do problems without any help. For example, solving 5x plus 8 is equal to 20, 7x minus 10 is equal to 25. Check for understanding. CFU. What are CFUs? CFUs refer to the strategies teachers use during instruction to assess whether the students are understanding the concept as it is being taught. It helps teachers make real-time decisions. Should I move forward? Do I need to reteach or clarify? How CFU is used in the handbook. Teacher asks 2 types of questions. 1. Factual and open-ended questions. Teacher diary and reflective practice. At the end of the completion of the topic, teacher has to record the concepts covered in that period. Period numbers ensuring structured and timely syllabus completion. Reflection questions for teachers help evaluate the effectiveness of the lesson and guide improvements in future teaching. What were some of the specific strategies that I used to encourage participation? How effective are they? What will I do differently next time? I asked questions to guide the students, but many of them didn't join in the activity because they didn't know enough content. Next time, I will guide them by giving instructions. Second, a reflective question. Were there any concepts or activities that students found particularly difficult? How will I adapt my approach to address these difficulties in the next lesson? Students find it difficult to solve quadratic equations. In the next lesson, I will use TLM, algebraic tiles, to help them to solve some quadratic equations. What additional resources or modifications could improve the effectiveness of the lesson in future implementations? I will conduct quizzes, paper mode quiz before 15 minutes end of the class for the effective completion of the period. How well did I adjust my teaching based on student reactions or unforeseen challenges? Many students like to learn through videos, so I will use more visual aids and I will keep focus on audio visual aids. Teacher notes. Here the teacher records the information or content that will be useful for future classes for effective teaching. Really, teacher handbook is a powerful guide to effective teaching. It has so many tools like concept maps, outcomes, TLMs, QR codes. It promotes alignment, engagement, reflection. By using teacher handbook, together we can build inclusive, interactive and effective classroom. Wish you all the best. Thank you, my dear friends. Hello everyone. Today I am going to present the period plan for arithmetic progressions of class 10th, chapter 5. In this video I will show the period plan step by step very clearly. First, I would like to highlight the learning outcomes of this chapter. We all know the importance of the learning outcomes. These are the key goals that students are expected to achieve by the end of the class. By the end of the class, students will be able to explain what a progression is. Student will be able to explain what a progression is. Student will be able to write an arithmetic progression with the given parameters. Students will be able to find the common difference and nth term of any given arithmetic progression. Students will be able to extend any given arithmetic progression if common difference and first term are given. And students will be able to find the problem of n terms in an arithmetic progression. And finally, students will be able to utilize the knowledge of progressions in real life situations more effectively. My dear friends, now I am presenting a concept map. Here is a concept map. To help students understand the topic better, I am presenting a concept map to you. It shows the main ideas and how different subtopics are connected. This concept map provides a quick and comprehensive overview of arithmetic progression. It explains 4 subtopics: definition or introduction, general form, nth term, sum of n terms in 2 ways. So it is a very crucial one. At the end of the class, student will be able to draw the concept map also. My dear friends, now we move on to period allocation. That means how many periods are allotted to our class. You are observing that 5.1 introduction, 5.2 arithmetic progression, 5.3 nth term of NAP, 5.4 sum of first n terms of NAP. Total number of periods are 4. These are instructional periods. So total number of instructional periods are 4 and 6 more non-instructional periods are also allotted. So total periods are 10 allotted to this chapter. Prior concept skills. Before starting today's lesson, it is important to recall the concepts that students have already learned in our previous classes. In previous classes, the student know these concepts: natural numbers, whole numbers, integers, rational numbers and irrational numbers, even, odd, prime and composite numbers, and finally patterns and sequences. These foundation ideas will help students understand the current topic more easily and connect new knowledge to what they already learned. So we have to keep more focus on prior concept skills. Here are some teacher references are there: SCRT AP textbook, Vedantu, NCRT solutions, Byju's content, and some more videos which explains the arithmetic progression effectively. My dear friends, first time we are hearing misconceptions. It is a beautiful concept, that is misconceptions. Students sometimes carry wrong ideas about certain topics while they are learning or while they are doing some problems. Let us see the misconception 1. If a sequence is increasing, it must be an AP. Many of the students think that arithmetic progression with d is greater than 0 is a sequence. If d is equal to 0 or if d is less than 0, they never see such type of arithmetic progressions. That's why they think that the sequence is increasing. If the sequence is increasing, it must be an AP. Here observe the example: 5, 3, 1, minus 1, minus 3. The difference between any two numbers is minus 2. 3 minus 5 is equal to minus 2. 1 minus 3 is minus 2. Here d is less than 0. And another misconception is 0 cannot be the common difference. It is also new thing to them. They observe many arithmetic progressions with d is greater than 0. Sometimes d is less than 0. But when d is equal to 0, the arithmetic progression is a constant, repeats the constant. Here is an example: 6, 6, 6, 6, and so on. It is a rare arithmetic progressions, model of arithmetic progressions. That's why students think that 0 cannot be the common difference. My dear friends, now we move on to teaching learning material, which is very, very crucial to understand the topic. To make the learning process more engaging and meaningful, we have to use teaching learning material. You all know mathematics is a dry subject, and so many teachers think that no TLM for mathematics, but there are so many teaching learning material for this chapter, arithmetic progression. First one is calendar. It is used to introduce the number patterns, dates as sequences, and to engage students in identifying arithmetic progressions in real life. And the second TLM is Pascal triangle. Oh, this is very huge one. It helps students discover number patterns, understanding combinations. And third teaching learning material is algebraic tiles with the labels A, D for finding nth term. And fourth teaching learning material is algebraic tiles to deduce the formula for sum of n terms of and arithmetic progression. So friends, very interesting teaching learning material are there. Here are some images. I am taking the month of July, calendar month of July as a TLM, and Pascal's triangle, algebraic tiles to find nth term and find sum of n terms. So friends, these are the teaching learning material. Now we move on to teaching learning process. It plays a crucial role in designing an effective period plan. A well-structured introduction, an engaged hook activity, meaningful experiential learning, thoughtful reflection, and purposeful use of subject-specific vocabulary form the main pillars of the teaching learning process. The teaching learning process starts with a good introduction. When we teach arithmetic progression, we can show students number of variety patterns see every day. For example, we can talk about a stack of glasses, steps of a ladder, the number of squares on a chessboard. We can also tell the famous Fibonacci rabbit story to show how patterns repeat in nature. Hook activity. A hook activity is an interesting task that catches students' attention towards us, makes them excited to learn the lesson. There are so many interesting and fun activities we can do. For example, we can use a calendar to show different sequences. From the second image, we can also see the number patterns the student can easily spot. On the top row, 1 glass, second row, 2 glasses, third row, 3 glasses. In the same way, the student can easily spot number of patterns. One of the best hook activities is showing the beautiful patterns in Pascal's triangle. In this Pascal triangle, we can find natural numbers, triangle numbers, tetrahedral numbers, acoustic numbers. So many number patterns will be found by the student. By showing these real life and simple examples, students get curious and want to learn more about arithmetic progression. Friends, now let's do a small magic with a calendar. This will help us how calendars can be a great source of number patterns and sequences. First, I have taken a calendar of month July 2025 and pick a grid 4x4 grid and draw a box around these 16 dates. 1, 2, 3, 4, 8, 9, 10, 11, 15, 16, 17, 18, 22, 23, 24, 25. You may take any grid of 4x4. Now, I choose one number from those 16 dates. Friends, do it parallelly. Choose any one number from those 16 dates and circle it. I have chosen 8 and circle it. And strike out the whole row and column where that number is. Again, from the remaining numbers, choose another number and repeat the same. Circle it, strike out its row and column. Now I have taken 3 and do the same as early. as previous. Again pick one more number and do the same. Yes, I have taken 23 and did the same. One number is left, that is for me 18, and circle that number also. 18. In the end we have 4 circle numbers. Add them all. But wait, don't say the total yet. I will tell you the total. Is it 52? Amazing. Even though we all picked different numbers, the total is the same. How did this happen? This is the magic of number patterns and sequences in a calendar. Friends, try this magic trick at home with different grids, with different patterns. You may take 3x3 also and explore the secret behind it. Thank you, friends. My dear friends, once again I say that a calendar is one of the best teaching learning material for all mathematics teachers. It helps us understand many maths ideas in an easy and interesting way. With a calendar, we can find hidden number patterns. Let us see how. First, take a calendar of 1 month. Now I have taken a calendar of the July month and draw a diagonal line from top left to bottom right. Look at the numbers. We will see a pattern. Now draw a horizontal line across any row. The numbers also follow a sequence: 13, 14, 15, 16, 17, 18, 19. Next, draw a diagonal line from top right to bottom left. Again we will see another pattern: 5, 11, 17, 23, 29. Draw a diagonal line from right bottom to top left. We can observe a pattern: 26, 18, 10, 2. It is the most important pattern because it has a difference less than 0. On the calendar, each time we will find a new pattern or number sequence. We can also draw vertical lines also. This shows that a simple calendar is a wonderful tool to learn and enjoy the maths. Here is another interesting hook activity that children already know is the popular ball game played at many jatras, festivals and carnivals. Just like in the picture, a boy is playing that game, Komaragiri Pongal celebrations. Some glasses are arranged in pyramid shape. For example, 1 glass on top, then 2 below it, then 3, then 4 and so on. Here the challenge of that boy is to knock down all the glasses by throwing a ball, but the goal is to do it in the fewest attempts. This game is exciting and shows a clear pattern. If we count the glasses in each row, we will see they form a number sequence. By asking questions, we will get pattern from the students, like how many glasses are there in a first row from the bottom, how many glasses in a second row from the bottom, how many glasses in the third row from the bottom. So likewise we can obtain a pattern from the students. This simple game helps children understood how numbers grow step by step. It is a great way to introduce the concept of sequences and series in maths in a fun way. Teachers can use this game to ask students questions like how many glasses are there in total? How many glasses will there be if we add one more row? In this way, a simple festival game becomes an interesting maths activity that everyone enjoys. Here is a beautiful look activity by using Pascal's triangle. By using Pascal triangle, we can explore many sequences like natural numbers, triangle numbers, tetrahedral numbers, Fibonacci sequence, symmetry, artistic pattern, powers of 11, odd and even patterns, and so many. There are a lot more patterns we can find in Blaise-Pascal triangle. After hook activity, we have to write the experience and reflections of the students. After learning about patterns in our daily life, students understood to prepare some number patterns. Now we move on to period plan. This is the period 5.1 LO1. Period 5.1 means 5th chapter first period. LO1 means learning objective 1. That is, students able to explore number pattern in the nature and real life situations. And the subtopic is introduction. My dear friends, now we move on to period plan. In this period, we will do more than 4 or 5 activities with the children. All these activities are group activities. Sharing with peer, the whole class will do these activities. Our duty is to instruct them, guide them, and motivate them. Let's look at the activity 1. Reena applied for a job and got selected. She has been offered a job with starting monthly salary of 8,000 rupees with an annual increment of 500 rupees in her salary. Her salary for the first, second, third and so on years will be respectively 8,000, 8,500 and 9,000. Observe the above situation and write Reena's salary for the next 5 years. What we have to do? We have to ask the children to read the activity 2 or 3 times and identify the data, what the problem needs. Here, the monthly salary of Reena is 8,000 rupees and annual increment is 500 rupees. By using this data, we can easily do this activity by our students. Now let's do the activity 1. Starting monthly salary is 8,000 rupees. What is the annual increment? Students will reply. Again ask them for the salary for the second year. Definitely they will reply that 8,500 rupees. How we get the salary for the second year? By adding 500 rupees to the 8,000. Let's do the activity 1. We will guide the students by asking questions. What is the salary? Starting monthly salary. What is the annual increment? What is the salary for the second year? What is the salary for the third year? By asking like these questions, the students can do the entire activity. The salary for the second year is 8,500 rupees. Salary for the third year is 9,000. Salary for the fourth year is 9,500. And salary for the fifth year is 10,000 rupees. Let us look at activity 2. Lengths of the rungs of ladder decrease uniformly by 2 cm from bottom to top. The bottom rung is 45 cm in length. Find the lengths in centimeters of the first, second, third up to 6th rung from the bottom to the top. Friends, we have to observe, we have to notice, we have to remember here the conditions. Decrease uniformly by 2 centimeters. Decrease uniformly by 2 centimeters and from bottom to top, not top to bottom, bottom to top. Okay. Now we will encourage the students to do the activity as whole, as group, as peer group, by asking questions, by giving some instructions, and some more strategies we may follow. Here the solution. What is the length of the bottom rung? 45 centimeters long. Each rung above is 2 centimeters shorter than the rung just below it. So, what is the length of second rung? 43 centimeters. How can you obtain it? Definitely he will reply that by subtracting 2 from 45, they get 43 centimeters. What is the length of the third rung? 41 centimeters. For finding the fourth rung, how many centimeters will be subtracted from 41 centimeters? 2 centimeters, that is 39. What will be the length of fifth rung? That is 7. And finally, what is the length of sixth rung? 35 centimeters. So the lengths of rungs from bottom to top are 45, 43, 41, 39, 37 and 35 centimeters. Students actively participate in this activity as a whole or group, and they will obtain a beautiful pattern. Now let us see activity 3. The number of unit squares in squares with side 1, 2, 3 units are respectively 1, 4, 9 and so on. What pattern do you observe in this situation? Is this pattern is the same as previous one? First, we have to find the pattern and we have to give explanation as is this pattern is the same as the previous one. If side is equal to 1 unit, how many number of unit squares are there? 1 into 1, that is equal to 1. If side is equal to 2 units, the number of unit squares will be definitely 4. 2 into 2 is equal to 4. If side is equal to 3 units, the number of unit squares will be 3 into 3 is equal to 9. If side is equal to 4 units, number of unit squares will be 4 into 4 is equal to 16. By asking questions like this or by giving some instructions like this, we will encourage the students to do this activity. So the pattern is 1, 4, 9, 16. These numbers are square numbers. 1 square, 2 square, 3 square, 4 square. Each number is the square of the side length. Now find the difference between the two consecutive numbers in the pattern. 4 minus 1 is equal to 3. 9 minus 4 is equal to 5. 16 minus 9 is equal to 7. Here the differences are 3, 5, 7 and so on. Differences are. So it is not same as the previous one. We can find the difference as fixed difference in the previous one, but here the difference varies, changes. So it is not same as the previous one. Now let's do another activity. Activity 4. Shilpa puts 100 rupees into her daughter's money box when she was 1 year old and increased the amount by 50 rupees every year. The amounts of money in rupees in the box on the first, second, third, fourth birthdays was 100, 150, 200, 250 and so on respectively. What pattern do you observe in the situation? Tell the amount deposited when she was 8 years old. In the first year, a person deposits 100 rupees. How much money does he deposit in this first year? In the second year, he adds 50 rupees more than the previous year. How much does he deposit in the second year? Answer will be 150. In the third year, again he adds 50 rupees more. How much money does he deposit in the third year? Answer will be 200. In the fourth year, how much does he deposit if he keeps adding 50 rupees each year? The answer will be 250. What will be the deposit amount in the fifth year? 300 rupees. What will be the deposit amount in the sixth year? 350. What will be the deposit amount in the seventh year? The answer from the students will be 400 rupees. What will be the deposit amount in the eighth year? Finally, the students will find the amount deposited in the eighth year. It will be 450 rupees. So the pattern 100, 150, 200, 250, 300, 350, 400, 450, 500 and so on. What do we observe in this situation? What do we observe in the pattern in this situation? The difference between the numbers in the pattern is fixed, that is 50. Let me introduce a beautiful activity, Fibonacci rabbit story. Suppose a pair of rabbits, one male and one female, is put in a field. Rabbits take 1 month to mature. After that, each pair produces one pair of rabbits. One male and one female, every month. The new rabbits also follow the same reproduction rule. If no rabbits die, how many pairs of rabbits will there be after each month? Now we will explain the Fibonacci rabbit story. Here for the first month there is a young black couple. It is not adult. Young black couple. For the first month there is one pair. In the second month that young black couple matured and it becomes adult black couple. In the second month also there is one pair. After mature they produce one pair. So in the third month the red twins for black couple. In the third month they produce one new pair, red pair. Once again, In the first month, we start with one pair of rabbits, one male and female. In the second month, they mature but don't reproduce yet. Now they become adult. Still one pair in the second month. In the third month, the pair is mature, so they produce one new pair, that is red new pair, red twins for black couple. Now we have two pairs. In the month 4, the original pair produces another pair. The new pair from month 3 is still maturing. Total, we have 3 pairs. In the month 4, blue twins for black couple. In month 5, original and month 3 pair reproduce 2 new pairs. Black twins for black couple, green twins for red couple. Total 5 pairs. In the month 6, original pair gives birth to one pair, twins for red blue couples, and total will be 8. This creates the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13 and so on. Now it is the time to conclude our period plan with check for understanding. Check for understanding has 2 types of questions: factual questions, open-ended questions. Factual questions are the questions questioning on only facts, that is on concepts. Open-ended questions are the questions which are not pre-defined questions. So now look at the factual questions. Collect different patterns at your surroundings. Does the roll numbers of your class follows any pattern? Open-ended questions. How does the length of shadow change during the day? It is a beautiful question, open-ended question. What pattern do you see in the way pine cones or sunflowers are arranged? So period plan ends with check for understanding. Now our session concludes with 5 beautiful multiple choice questions. They have some purposes also. Which pattern has a common difference of 0? 5 5 5 5 0 2 4 6 1 3 5 7 2 4 8 16. This is asked to reveal the importance of the misconception 2. It will clarify the doubts of the students. Which pattern represents equal jump of plus 4? 1 4 7 10 2 5 8 11 3 6 9 12 4 8 12 16. Which pattern starts with 4 and adds 5 each time? 4 8 12 16 4 9 14 19 4 5 6 7 4 6 8 10. Which sequence has equal gaps of -2? This is asked to clarify the doubts on misconception 1. -1 1 3 5 5 3 1 -1 2 4 8 16 2 1 0 -1. What is the next number in the pattern? -2 0 2 4 and so on. It is asked to continue the lesson progressions. So every question has a purpose. We may ask the students to prepare some patterns based on these multiple choice questions. Thank you.